Hello, hi everyone. My name is Kamesh Pemmaraju. I'm a senior product manager with the Dell OpenStack Cloud Solution Group. Today we're going to be talking about how wicked easy it is to use Ceph and OpenStack and install them using Crowbar. So quick check of hands here. How many of you guys actually use Crowbar or heard Crowbar? Okay, well, how about Ceph? Excellent. So that's fantastic. So today we're going to talk about a few things. For those of you who don't know what Dell has been doing in the OpenStack community, I'll give a very quick introduction to that, an introduction to what Ceph is all about, and an introduction to Crowbar. So we'll start off with that, and then we'll go into why Crowbar and Ceph. What problems are we trying to solve? There is this OpenStack storage gap, specifically in the block storage area. And we'll talk about how the solution addresses that gap. It's mainly around automation and scale. We'll talk about that. And then what we have been doing with Inktank and Dell, we've been working together for several months in the community, and now we have a partnership with them. So what have we done to enable things for our customers? And then in the end, I have a specific example of a customer installation that's actually going on as we speak. So I'll give a very quick overview of what's going on there, and very quickly on what's coming next. So that's kind of the agenda. So let me quickly jump into a little bit of a background on Dell's point of view around OpenStack clouds and what we've been doing. So if you look at any cloud installation, right, it requires hardware, it requires software, but the majority of it is really all about operations, right? So where do you spend most of your money and time? It's in operations. So things like, when you run out of capacity, you have to add more servers. And when those servers are added, how do you make sure that those servers become part of your OpenStack cloud automatically? Right? What happens if a server goes down? What happens if you have to patch an operating system? What happens if you have to update all your changes in production? So all of that is operations, and it requires significant focus on those operational controls in production. And those decisions around what you do in operations drive your hardware and software decisions. So we have done a lot of work at Dell, and we'll talk about that because Crowbar encapsulates some of those best practices. So this is how the current solution looks like. So on the software side, we have OpenStack. We use OpenStack for our cloud solution. Ceph is the OpenStack cloud storage solution. We have a reference architecture and a taxonomy around the Dell hardware and Dell portfolio. And the big part of it, as I said, is ops. What do we do there? That's where Crowbar comes in, and there's services and consulting. So I'm not going to go into the details of this, but you'll see the cloud, the deck later on. But effectively, we have hardware. That is the PowerEdge and PowerEdge R series that are part of the solution. Storage and computer part of that. We use our own portfolio of 4-stent switches and Power Connect. The software is OpenStack software. The installer is Crowbar, which we will talk about as we go forward here. We use Ceph for distributed storage. The operating system we use today is Ubuntu 12.04. We support both Windows and Linux guests. KVM is, as you know, very popular hypervisor in the OpenStack world, so that's what we use for our solution as well. There's deployment and consulting, there's support. So when customers want to stand up an OpenStack cloud, it's not just a software piece, it's the entire end-to-end solution. And that's what Dell has been doing. We've been working with the community since day one. For those of you who may not know, we have been very active in the community. We ran the OpenStack meetups in Boston and Austin. We have been sponsoring the summits for a long time. So we're excited to be part of the community. We are doing a lot of work around Grizzly. So with that, I'm going to hand it over to Neil to give an introduction on Ceph, and I'll come back and talk about Crowbar after that. Here you
go. Thanks, Kamesh. So I'm Neil Levine, VP of Product at Inktank, who are a commercial sponsor of the Ceph project. So Ceph is an open source, massively scalable, distributed, software-defined storage system. And it combines 3 storage flavors in it. We've got the object storage. So if you're looking to do an S3 type service or use an alternative implementation of Swift, we're completely Swift and S3 API compatible. We also do the block storage, and I'll come to more of that later on. So this is a way of abstracting out your block volumes from your VMs into a separate dedicated storage system. And finally, we have our POSIX compatible distributed file system, which is ideal for legacy workloads, but object and block is really where most of the OpenStack effort and integration work has been done in Ceph. So the key sort of values or differentiators that we have around Ceph other than a unified aspect, which in and of itself is a huge boon to those of you using OpenStack, you only have to deploy one system, is we have a very clever way of distributing data amongst the storage system using an algorithm called Crush. So when the clients are writing data to the storage nodes, they're using an algorithm to calculate where the data should be put and where it should be read from. This is very, very efficient and really gives Ceph a huge part of its scale story. This spans many, when you've got thousands of nodes, having a fast way to work out where data should be without having to go through an index table or do any lookups is a core part of getting that scale out. Additionally, we have what we call our intelligent devices or intelligent nodes. So these are self-healing, they're self-managing, and they're using a peer-to-peer mechanism, which again gives it this incredible scale, where all of these nodes are talking to each other, and as a way of working out which nodes are up, which nodes are down, which nodes are serving data, which ones are not. And every time you add a new node or you're taking nodes out, whether deliberately or because of failure, all the nodes communicate with each other what the state of the system is. So this kind of intelligence, which used to have to sit in the head of the storage admin, it is handled by the software. So scale here is not just about the amount of storage you've got, it's about the number of people you've got to manage the system. We work very hard to get the intelligence down into the software so you don't have to do much as an admin. One of the sort of lesser-known features, but probably one of the most powerful ones within Ceph, is the ability to actually take an object class, if you're writing your application, and attach a piece of your application logic directly into the storage system itself. So this is a way of doing true distributed computing. So the example is that you could write a piece of software which is transforming a piece of data, whether it's an image or a video. You maybe want to create a thumbnail or encode it. You can create the software that does it, the application code, and embed it into the storage system itself. So this is application-aware storage development. So this means you don't have to have an application take data out, transform it, write it back again. It all happens directly on the nodes themselves. And finally, as we'll go into in more detail in a second, we're integrated into OpenStack quite heavily. We're also integrated into the Linux kernel. So on the block side of things, if you just want to mount a Ceph block image, you can just do that using any fairly modern kernel. So from an architecture point of view, whether you're accessing the system for object or block or the file system, it's all built on our object storage system itself called RADOS, which has an acronym which I won't go into. RADOS is really the sort of the heart and soul of the system, and it's where the true scale out happens. It's where the intelligent nodes sit. It's where you put the object classes if you're writing code, and it's a thing which is you're going to be scaling out here. The clients on top, whether it's object or block, are very thin pieces of code generally, which are sitting on your VMs in the case of the block device. And you also scale these out as well, but you'll be handling that in a different capacity planning decision through the block, as you will from the underlying RADOS system itself. So RADOS consists effectively of two components. We have monitor nodes, which are watches of the system. These are the nodes which are deciding which object storage nodes, or OSD nodes, are up and serving data, which ones are not serving data. So the monitor nodes themselves they're not part of the transaction between the client and the server. They're merely there to monitor the state of the cluster. And again, they use Paxos as a consensus algorithm to decide what the state of that cluster is, and to inform both the OSD nodes themselves so they know who's up and who's not, but also the client. So the client itself gets a copy of the topology state from the monitor and uses this as part of the Crush algorithm to work out where the data is going to be. So you'll have a bunch of monitor nodes, preferably an odd number, so you can get quorum in a split brain situation, working out the state of the cluster, and then the OSD nodes themselves, which are, again, the heart and soul of the RADOS system here. So typically you'll have one OSD process running per disk, although you can aggregate multiple disks and have a single process monitoring that as well. And each OSD can also have the object classes attached to it, as I mentioned before. So a general Ceph cluster will look like something like this, where you'll have 3, 5, 7 monitor nodes, a relatively small number, and a lot of object storage device nodes, OSD nodes as well. Now, the OSDs themselves consist of just a raw disk itself, a SCSI disk or a SATA disk or so on. We'll layer a standard file system on top. We typically recommend XFS. We're looking at Butter, and we do have people using Butter who are adventurous, and ZFS is also beginning to look attractive now. But these are standard Linux file systems, and then the OSD process on top. So from a provisioning point of view, these are fairly standard components, just basic disk presented to kernel, fairly standard file system, and just part of our Ceph packages included in the Dell OpenStack solution, all layered on top of each other. And it's this layering and this distribution of the OSD nodes, which is where the deployments or the main effort around your deployment will be focused. So this is where I'll hand back to Kamesh to talk a little bit about how Crowbar handle these layers of deployment.
Thanks, Neil. So we'll come back to Ceph, about how Ceph works with OpenStack in the next session. So let's do a quick introduction to Crowbar. For those of you who have not heard of Crowbar, I just got off of a session this morning with Best Buy. And Crowbar is open source, by the way. And it turned out that actually Best Buy is using Crowbar, and we didn't know about it, which is how open source works, I guess. But anyway, what's Crowbar? Crowbar is, the way we define it is basically, if you have, think of a scenario where you get a whole bunch of raw servers just show up at your doorstep. And from that point on, you want to get your OpenStack cluster up and running. What does it take for you to do that today? Right? Think about that. There's a ton of stuff you need to do at the networking layer. There's a ton of stuff you need to do for setting up your DNS, your DHCP, your IPMI. There's a whole series of things you have to do before your infrastructure is ready, let alone the OpenStack stuff. Right? There was a user survey that came back this morning. I don't know if you have seen it. It's out there. The user committee has actually done a survey in the last 2 weeks, and they surveyed about 415 people in the community, various people, users, operators. What was their number one challenge? Any guesses? It was installing, configuring, and managing OpenStack, right? And I'm talking about one layer of more difficulty down below that at the infrastructure layer. And this is what this is the problem that Crowbar solves for you. It automates the entire process of bare metal provisioning and getting OpenStack and the operating system, everything up and running for you in an automated fashion. So from a marketing point of view, we say get your servers in boxes to a full functioning OpenStack cloud under 2 hours. So that's sort of the mission statement for us. It's fast and flexible. It's bare metal install using, so even if you have servers show up, there's all kinds of stuff inside that server. There's BIOS, there's RAID, there's IPMI settings. The servers have different ways of handling your actual hardware. So somebody has to go in there and do stuff. I mean, they have to go update the firmware. They have to go configure the BIOS. If you're doing that manually, that's not cloud. It needs to be automated. It needs to be done at scale, right? And that's what Crowbar does for you. It's all DevOps. I mean, the whole idea is DevOps. So it's an ongoing operational model. So as you learn how to do these things that you do manually today and take those best practices and program it back into your system, in an automated system, that's what Crowbar does for you. It's open. So by the way, for those of you who followed the Best Buy story this morning, Crowbar, they're not using Dell servers. That was the entire HP stack that they showed in that picture. So Crowbar actually works on other servers too. It's not Dell specific. It's not specific even to OpenStack. You know, we've actually used Crowbar to deploy Hadoop clusters. And Neil will talk about it. We use Crowbar to deploy Ceph clusters. So you can use it to deploy any application. And it's Apache 2 license. It's all open source, so you can go get it out there. So I just wanted to spend a little time about talking about the soup versus the sandwich analogy. So for those of you who are in the virtualization world, right, you're all familiar with golden images, right? Golden images is what we refer to as soup. So you've got your applications, you've got your utilities, your operating systems, you sort of build all these together, and you create this wonderful, great-looking golden image, and that's what you deploy, right? But that model, there are pros and cons of using that. The downside of it is even if there's a single change, if there's a little patch to the operating system, if you have 1,000 servers out there, how are you going to go deploy that? So you create another golden image, you go deploy that, right? So that's the soup model, or the single unit model. It's a single golden image model. There's the other approach is to take a layered approach, right? So you have all these different pieces that you see there, the layers, the sandwich model, right? The operating systems, applications, et cetera. And the idea is you can take each of those things and manipulate them in production, one layer at a time. So you get a lot of flexibility doing that, right? So this is how it works in an upgrade, right? In the case of an upgrade scenario, Like I just said, you have to update an operating system, you create a new golden image, and you go off and deploy it to 1,000 servers. It's not scalable, obviously, right? This is where the whole DevOps picture comes into picture. So in the case of the layered model, just one component gets updated. And this is the whole philosophy behind Crowbar, which you'll see in a second. So this is Crowbar uses layers for deployment, all the way from physical resources to the core components and operating systems, the cloud infrastructure, OpenStack in this case, all the way up to the APIs, right? We'll get into more details here. Again, as I said, it's not exclusive to Dell. We have built it in such a way that it's modular. There's something called bar clamps, which we'll talk about in a second. But it's all modular, and it's all based on this layered philosophy. So how does Crowbar work? I'm not going to go into too much detail. If you want to drill into the technical details, come by the Dell booth. We have all of our rock stars, basically, from Dell here. Technical product managers, our engineers are all here. So they'll give you a quick tour of what it is. But basically what it does, imagine that you've got OpenStack up and running. Okay? Now you've found that all of a sudden you're out of capacity, right? Not just from a VM perspective. You're out of capacity from a physical perspective. Now you go add a new server. How do you do that today? It's a manual process, right? You go configure the hardware, you put it back into the cluster. But in the case of Crowbar, the moment you add the server, Crowbar discovers it. So there's this thing called there's a DHCP server, and we pixie boot. So there's a sledgehammer image that gets downloaded. It figures out what is on that server. How many resources does it have? What's memory? What are the networking configurations, the NIC cards, everything. And then it comes back and says, what do you want to do with this node? Do you want this to be a compute node? Do you want this to be a Ceph node? Do you want it to be something else, right? So you can allocate at that point. And at that point, you can say, and this is where the chef comes into picture. Everything that Crowbar uses is chef underneath, right? It's a master orchestrator, if you think of it that way. And then it lays down the operating system bits, it lays down the networking configuration, it lays down all the apps on top of it. This is all automated, by the way. And then there's a whole orchestration cycle, right? It's a complete state machine that takes you from bare metal all the way up to a running app. So that's basically what it is. So basically, Crowbar is a very configurable system. You can add these things called bar clamps, which are effectively things that you can use to extend the capability of Crowbar. I'm not going to go into the details of this, but again, it has a Crowbar API. It's called chef recipes in it. It's components and scripts you can use to extend Crowbar to deploy your own application, which is what Neil will talk about shortly. But again, if you look at the overall picture, all the physical resources, this is what I was telling earlier, networks, RAIDs, BIOS, IPMI, all of these things you can't overlook in any real cloud deployment. And at scale, this becomes a huge issue. And then at the operating system levels, you may be using multiple operating systems. You may be a Red Hat shop, or a SUSE shop, or a Ubuntu shop, or you want to have multiple things going on. How do you deal with that at scale? Again, the same kind of problem, right? And then on top of that, you have all the OpenStack components, Nova, Swift, Quantum, Cinder. You need to get all those components, and as I said earlier, configuration of all of these pieces in the right way, in the right order, so that they all work together is not easy, even today, even with Grizzly. And Crowbar does that for you. And at the top, you can use other things like Stratus and Ganglia and stuff like that. So I'm going to hand it back to Neil at this point. We'll go deeper into the Ceph stuff with OpenStack.
So to understand why deployment is so critical to this, it kind of helps understand some of the evolution that we've gone through, I think, over cloud, with the private cloud technologies, particularly with an OpenStack over the past couple of years. So when OpenStack and some of its predecessors began a couple of years ago, everybody said, well, the way to do storage was just to use object storage. It came as part of these solutions, and that was the brave new way of doing it. But of course, the reality was that most applications couldn't do object storage, that you were trying to, the readily available application you wanted to move to your cloud didn't have any concept of stateless storage. So everyone said, okay, you've got to re-architect. We can't re-architect. Let's just use local storage. It's quick and easy, and it's provided as part of these default installations. But obviously, local storage is not the cloud way of doing things. This is not really scale out. So when you start to see the storage admins coming forward and saying, well, we've got our existing proprietary appliances. Let's just use those, plug those into these open source clouds. But again, didn't really make sense that these weren't, again, true commodity scale out, which is really what cloud's all about. So we've arrived now at a point where people realize that distributed scale out storage is the way you do things. And this both applies for new applications, greenfield applications, as well as the legacy ones. And so we have people saying, I want to do storage like Google, I want to do storage like Facebook, which is what Ceph provides, but the deployment story is a large part of that. So we talked earlier on about Rados being the underpinnings or the foundations. There's no single point of failure, it's self-healing, it's got the crush algorithm and so on. So we talk about specifically about some of the block components, and then we'll see how Crowbar sort of helps you deploy all of these pieces together here. So from a features point of view, Ceph with the block storage gives you standard kind of services of cloning and snapshotting, but it's got some particularly good features which make it suitable for OpenStack and OpenStack clouds. So first of all, remember Rados is an object storage system here. So when we have a block volume here, we're just chopping it up into lots of objects, and then we're striping those across multiple OSDs, multiple disks, physical servers in your Ceph cluster here. So just the abstraction alone makes it very easy to sort of have VMs die to remount in a sort of an EBS-style way the volumes that they were using. It then also opens up the door for live migration, which is an active topic within the Cinder group and so on. But let's think about how do you spin up images. If you want to spin up 100 images, what's actually happening here? Well, one way is you take your boot volume and you just copy it 100 times, but this is not very efficient. So we use a thin provisioning and a copy and write system to make this a bit more space and speed efficient here. So when you have your initial image here, which is, say, 144 blocks worth on the left-hand side, you can just clone that 4 times. And what we're cloning here is actually not cloning data. We're just creating an empty data structure which has a whole bunch of pointers back to the original image. So the ability to create those cloned copies is very, very fast. You're not actually copying any data at all. So booting up lots of images at the same time is very, very fast. Combine that with a thinly provisioned initial image where you're only maybe saying it's 2 gig big, but actually you're really only using 1 gig in practice. Again, efficient space optimization. Once you actually start writing data, once you've booted your volumes and are actually making changes to this initial image here, then the pointers get flipped into actual real data here. But of course, the client continues to read from the original image. So again, very, very efficient way of doing multiple boots of hundreds of volumes. Now, in terms of the OpenStack integration and how this all fits together here, so I mentioned the object gateway, which I won't go into now, but on the block device here, we're completely plugged into the Cinder API. So all of the Cinder API calls, with I think the exception of one, which isn't so important, are all implemented here within the Ceph Block device, which then also allows you to use Glance and have Glance use the block device with that copy and write capability to store your images in a very efficient way. And we've also modified the QEMU KVM hypervisor. So it's RBD aware, it can see these volumes, it can attach and detach them, and so on and so forth. So all of this is natively integrated, and it has been since Folsom. We're tracking all the API changes and making sure that they're all compatible with Ceph. Okay, so how does this come into the deployment story? So we have these OSD nodes, we have these monitor nodes here. You've now also got your RBD aware Nova compute nodes here. Now, ideally, you want to have these homogeneous blocks which are just scaling out. So when you talk about doing storage the way Google do it or storage the way Facebook do it, it's all about getting a completely homogeneous stack which you just clone repeatedly. And this is cloning both of the hardware. You want to have identical hardware reference architecture where possible, the operating system, and the applications on top, and just scale them out. And again, by abstracting out the storage, you can scale your VMs on the Nova compute separately to the underlying storage system itself, which has different characteristics and different times about when you want to scale this out here. So again, homogeneity, these kind of stuff, and getting this to be a repeated process where you just rack up 100 servers at a time or tens of servers at a time gives you your scale out and your scale down here. So from a practical point of view, how does this work with Crowbar? So as Kamesh hinted, we have these things called bar clamps, which are these modular pieces of code which allow you to sort of define specific roles or profiles for parts of the stack here. So at Inktank, we worked on the Ceph bar clamps, and they do a couple of things here. So first of all, you have the admin node itself acts as a repository manager for all the software that's deploying out here. So with Ceph, you can do rolling upgrades. We've got a 3-month release cycle at the moment. So all of those packages, the freshest, latest bits, are pulled into the admin node itself. Then you can allocate a particular machine as a monitor node or as an OSD node. It'll, as Kamesh hinted, it will do all of the hardware stuff, the IPMI, the networking, and so on and so forth. It'll get the right disks in place, and so it'll be aware that these are the disks which should be holding the data. It'll partition them up correctly. It will get the Ceph processes running on all of them. So the OSD and the monrolls all handled by the bar clamp. And then using just the standard Nova bar clamp, this is now RBD aware. So when the Nova bar clamp is provisioning the OpenStack software, it will ensure that the QEMU is configured to be aware that it can mount and unmount these RBD images. And back to Kamesh, just to explain a little bit about some of our customers and ongoing work.
Thanks, Neil. So we've been working with Inktank for a long time, even before they were Inktank. They were DreamHost at one point when they were doing Ceph. So we were involved in the community. Dell and DreamHost were working in the community. And then last year, we started really working with them on a more professional basis, right? So we partnered with them, and we built this Crowbar Bar Clamp. The Inktank folks did it. And so we have a joint solution today that we have brought to market. It's a Crowbar Bar Clamp, right? It deploys Ceph clusters, as Neil was referring to earlier. It's automatic. It's all real time. You can expand your Ceph clusters. You can expand your OpenStack clusters, and all magically works. And of course, customers still want professional services. They want support training. So that's all delivered through collaborative support from Dell. And when Inktank built the bar clamp, it's not just a software piece, right? It has to work with the reference architecture we have in place. So we went through a whole technology partner program, and the whole bar clamp and the whole OpenStack cluster with Ceph was validated against the reference architecture in our technology partner program and in our Dell Solution Center as well. So it's now ready. It's available in the market. And when we launched it back at Dell World in December, that was the official launch. And since then, we have seen tremendous interest in this technology with OpenStack and Ceph. It's just unbelievable the amount of inquiries that are coming in, how much people are interested in this stuff. We actually have a customer deployment that's going to happen next week. It's a university, and the situation, very briefly, I'm not going to go into the details, but this university has more than 900 researchers, and they receive hundreds of millions of dollars in grants as one of the top research institutions doing work on cancer and genomic projects. So it's big data. They do a lot of work with large amounts of data, right? So what the university was looking for was a centralized data repository, which they can ensure compliance, and they know exactly how much consumption is happening, et cetera, et cetera. And the intention was for the university to provide 2 terabytes of free data to all their researchers. And anything beyond that, they would charge the researcher a nominal fee. So that was their model, right? I mean, this is going to be a very large cluster. At the end of the year, they were talking about 5 petabytes. So the university looked at a lot of different solutions out there. They looked at traditional SANs. They looked at the public cloud storage solutions like AWS. They even looked at Hadoop to see if that would be a solution. And at the end of all that, they came to a decision themselves. All of this stuff was on the open source side. So they checked it out, and they came back and said, you know what, all of those solutions are very expensive. The traditional SANs are not going to help us. Hadoop was not the right fit for this. So they came back to us and said, we want the Dell Inktank solution because it fit our needs. It was the right cost point for us. It was the best of all the worlds for both compute and storage. They were interested in OpenStack. They were interested in Ceph. So we had a solution that best fit their needs. So what's coming next? Let me finish with what's coming from Dell. This summer, we are already working on Grizzly. Our team is completely focused on that. So we will have an officially supported Dell Grizzly release by this summer. There's a lot of work going on around Crowbar 2.0, which is the next generation of Crowbar. It's all happening in the community. It's open source. And we've been working very closely with SUSE. SUSE has been a great partner. Their SUSE cloud solution, by the way, is also uses Crowbar as their orchestration and deployment engine. And they've been working very closely with us in the community for Crowbar 2.0 development. We're doing a number of things in Crowbar 2.0. I'm not going to go into the details, but I think the most important thing is so today, if you look at all the cookbooks, we use Chef, right? And all the cookbooks for Chef are We want to upstream them, meaning that they're available to the community so they can use it to deploy their own OpenStack clusters. So we're trying to decouple the cookbooks from the Crowbar specific pieces. So that's another key thing. And come by the Dell booth and we'll give you more details on what that is. And Neil will talk about what's coming next on the Ceph side.
So as mentioned, Ceph has now got a 3-month release schedule, which is something we've recently changed. So Ceph Cuttlefish, which is the next major release, is coming out in a couple of weeks. Major features here, we've got incremental snapshots on the block device, which are really important when you're trying to do a copy of a block image from one cluster to another. You don't have to be moving the whole thing, you just move the incremental changes. We've also got a whole bunch of APIs coming in, so at the moment a lot of the functionality of Ceph you have to do through the CLI. We've got an API everywhere policy. So the first set of APIs are coming for the Rados gateway part, but the Rados system itself will be fully enabled from a provisioning and from a monitoring and management point of view through APIs in a dumpling release coming out in August. And also we've got geo-replication and multi-site for the object gateway coming then as well. And as Kamesh mentioned, we're going to be porting the bar clamps over to Crowbar v2. When Crowbar v2 sort of goes GA, we'll start work on that. We've got a session tomorrow, in fact, about the Ceph roadmap, and so people are going to get involved and sort of join us to plan out the next set of work, including the bar clamps work, but also the continuing integration of Ceph and OpenStack. We sort of invite you to come and join us for that. And then we've also got another session where if you really want to get into some of the detail, one of our engineers, Josh Durgan, is going to be giving a talk on Thursday where he'll focus on a lot of the Cinder stuff, but just be going to the sort of general changes that we've had in a previous release, Bobtail, and those which are coming up in Cuttlefish. I think that's it.
Yeah, so there's the contact information for us, and these slides will be up on the site so you can take a look. But with that, are there any questions, comments? Yes? In Crowbar? Great question.
So that's the question? 'Cause I didn't hear it.
Yeah, the question is, does Crowbar support Puppet? Today it does not, but the direction we're going with Crowbar 2.0 is for us to enable both Ceph and Puppet support. Yes. Other questions? Yes.
More for the Ceph side.
Yeah.
So, is there anything in the plans for immediate write acknowledgement? So instead of waiting on the write plus the replica, that once one write is acknowledged, that you would need, maybe a setting for that.
There is already a setting for that. You can set the mandatory number of writes which have to be done. Sorry, the question was, is there a way to sort of get it to not have to wait for all the replicas to be created before a success is returned back on the write? It's already a configuration in the crush rules where you can say, if you've got a replica of, say, 5, you can say, just give me 2, 3, and return a success, and then the rest will happen in a lazy, eventually consistent way.
Is that in Bobtail?
Yes, it is, yeah.
Okay.
Any other questions?
Okay. Well, thank you very much. Well, there's another
we've got
question.
one more down here. Yeah.
What's the future of Crowbar and Heat? How do they play together?
Crowbar and Heat. So if you have been to some of the sessions from Rob Hirschfeld, who is our chief architect, there have been some discussions around that. I don't know if there's anything specific going on right now. Yeah. Okay, thank you very much.
Thank you.